So today I am going to start exercise questions. Now in that question number 13.1, that is classification of amine, that you can do at your own. So that's your homework. Question number 13.1, that is your homework. I am going to start question number 13.2 here. The question is like this. Give one chemical test to distinguish between the following pair. In that first number, methylamine and dimethylamine. Now here you can see this one is methylamine CH3NH2. It is 0 degree amine, you can say, or 1 degree amine. Now dimethylamine, it is 2 degree amine. So we have to distinguish between 1 degree and 2 degree amine. So for that we have carbyl amine test. We have seen that reaction in theory also. Carbyl amine test. Primary amine gives carbyl amine test, but secondary amine do not give carbyl amine test. The reaction is like this. When primary amine reacts with chloroform in presence of KOH and we heat it, it gives isocyanide as product. As byproduct we get KCl and H2O. Now this isocyanide is having very bad smell. I told you that in theory also. So we can identify by this reaction whether which one is our primary amine and which one is secondary amine. If substance gives reaction and it has bad smell, then it is our primary amine, and second one is our secondary amine. So by this test we can separate primary amine and secondary amine. Carbyl amine test. Now the next reaction is secondary and tertiary amine. Now we want to distinguish between these two compounds, secondary and tertiary amine. So for that we are going to use Hinsberg reaction. When 2 degree amine means secondary amine reacts with Hinsberg reagent, it gives sulfonamide product. Now 3 degree amine, it does not react with Hinsberg reagent. So you can see this one is our 2 degree amine, this one is our Hinsberg reagent. Benzene sulfonyl chloride. 2 degree amine when reacts with benzene sulfonyl chloride, it gives us this product. You can see remove H and Cl and attach this both structure. So you will get sulfonamide product. Now secondary amine gives this reaction, but 3 degree amine plus H2O does not give reaction. So you can identify which one is our secondary amine and which one is our tertiary amine. The next pair is ethylamine and aniline. Now you can see here ethylamine CH3CH2NH2 and aniline on benzene ring NH2 is there. Both are primary, but this one is our aliphatic amine, simple carbon chain is there, and this one is our aromatic amine, benzene ring is there with NH2. So how we can distinguish between aliphatic amine and aromatic amine? So we have to react but both the compound with nitrous acid. Now for nitrous acid I am using this both compound NaNO2 and HCl. They both will react together to form NaCl plus HNO2. This one is your nitrous acid, HNO2. Now this HNO2 when reacts with aliphatic amine, it gives us diazonium salt. Now this diazonium salt, when we dissolve it in H2O, it gives us alcohol plus nitrogen gas plus HCl. But when this aromatic amine reacts with nitrous acid at 0 to 5 degrees Celsius, it gives us same diazonium salt. But here you can see no nitrogen is produced. Here water is produced. When this diazonium salt reacts with water, it does not give nitrogen gas. So whichever compound liberates nitrogen gas, you can see the nitrogen gas evolving in the reaction. So if a compound gives reaction and evolve nitrogen gas, then the compound is ethylamine. But if compound reacts and does not give nitrogen gas, so it is aniline. Okay. Next one is aniline and benzylamine. Now here you can see this one is our benzylamine, this one is our aniline. You can see benzylamine is aliphatic amine and aniline is aromatic amine. So we have seen this reaction, same reaction applies here. Just instead of this ethyl group, we have benzyl group. So same theory applies here. Reaction with nitrous acid. When aliphatic amine reacts with nitrous acid, then water, it evolves nitrogen gas. But aromatic amine means aniline does not evolve nitrogen gas. So we can differentiate between that two compounds. The fifth one is aniline and N-methyl aniline. Now you can see this one is aniline, this one is N-ethyl aniline. You can see aniline is primary amine and methyl aniline is 2-degree amine. Differentiate between these two. So we can use primary and secondary amine are there. So we can use carbyl amine test. Primary amine gives carbyl amine test. Secondary amine does not give. If a question is there in a board exam, you have to write down the reaction also, like the previous one. Okay. The next question is 13.3 number. Account for following, means we have to give reason for the following statements. First one is pKb of aniline is more than methylamine. Now what you have to remember for this question is strong base has less pKb value and weak base has more Kb value. Again, what we have to remember here, strong base means less pKb value, weak base means more pKb value. So indirectly we have to prove here that aniline is weak base. Aniline is weak base, that we have to prove here. So you can see this one is aniline. Now aniline has 2 non-bonding electron on nitrogen. That non-bonding electron participates in resonance structure. So it can give 5 resonance structure. You can see here. Now in methylamine, no resonance structure is there. So aniline is more stable compared to methylamine. Here you can see, as shown, aniline has 5 resonance structure, so it is stable, not strong base. But methylamine is not having any resonance structure, so it is stronger base than aniline. Now stronger base means less pKb value, weak base means more pKb value. That's why aniline has more pKb value than methylamine. Now second statement, that is ethylamine is soluble in water but aniline is not. Ethylamine is soluble but aniline is insoluble in water. Now you can say this one is our ethylamine. It has NH2 group and a aliphatic chain, small aliphatic chain, 2 carbon chain. Now this NH2 can make 2 hydrogen bond with water. You can see here these 2 bond. It can make 2 hydrogen bond with water. So it is soluble in water. But in case of aniline, this one is our aniline. Now aniline does not make any kind of hydrogen bond, so it is insoluble in water. Next statement, third number. Although amino group is orthopara directing group, but on nitration it gives meta-nitroaniline. Okay. Here amino group that we are talking about. So amino group is NH2. When aniline reacts with nitric acid to give nitration reaction. Nitration reaction means we have to introduce NO2 group in it. So we are reacting it with HNO3. Now this one is base, this one is acid. So acid-base reaction takes place here. Instead of nitration reaction, acid-base reaction takes place here, and it makes salt. You can see here this salt, it makes salt. So instead of nitration reaction, it gives us acid-base reaction and makes salt. That's why now this salt, anilinium salt, if we add more HNO3 after making of this salt, if we add more HNO3, it gives nitration reaction. But now our starting material in that reaction is this salt. Now this salt is meta-directing group. That's why as resulting product we get meta-nitroaniline, and we do not get ortho or para-nitroaniline. Next one, aniline does not undergo Friedel-Crafts reaction. Why is that? So Friedel-Crafts reaction, we learned that in 11th standard we learned Friedel-Crafts reaction, alkylation and acylation. Now in that anhydrous AlCl3, that is our catalyst. In presence of AlCl3, we can perform the reaction. Now anhydrous AlCl3 is acidic in nature, and aniline, that is base. You can see base plus acid. Again, it gives acid-base reaction to make this salt, anilinium salt, and this salt, our catalyst is used in making of this salt. So alkylation or acylation does not take place here, because our catalyst is used in making of this, in preparation of this salt. That's why alkylation or acylation, that does not take place in aniline. Fifth one, Gabriel thalamide synthesis is preferred for synthesizing primary amine, 1 degree amine. Now look at the reaction, Gabriel thalamide synthesis. You can see this one is our thalamide. When it reacts with strong base KOH, now this is base, so it has tendency to gain H+. It attracts H+. So this hydrogen it takes and makes H2O. So minus H2O will be there. Now this K+ ion is free. So with and minus, this K+ attaches and makes this ionic bond. Now in next step, alkyl halide reacts here to give this product. Instead of K we have R now. Now K and this X, K and this X, they will form KX as byproduct. Now in last step we have to react it with again strong base to form amine. Now this is primary amine. Okay, if we want to produce 2 degree or 3 degree amine, then what we have to do? In this step we have to react more than one alkyl halide. In this step we have to react more than one alkyl halide, and there is no space for it. There is no space for reacting more than one alkyl halide. So that is called steric hindrance. Again, you have to write this particular word, steric hindrance. You cannot write that there is no space for more than one alkyl halide to react. What you have to write? You have to write that due to steric hindrance, more than one alkyl halide cannot react here in second step. So it is not possible to produce 2 degree or 3 degree amine by Gabriel-Thalamide reaction.